we're going to talk about solutions and why things dissolve and how they interact. So by the end of this video, you should have a better idea of how things are going to dissolve and whether they will or won't. First thing we're going to start with is the word miscible. This is a new word for you, and it means a liquid that is soluble in another liquid. Easiest example to think of is anytime you've applied food coloring in the water in my class, the food coloring is able to dissolve out through the water. That's what we call miscible. A liquid that is soluble or will dissolve in another liquid is miscible. Now, if miscible means it will dissolve, the prefix "im" in Latin means not. So a liquid that is not soluble or insoluble in each other is immiscible. Think about oil and water. Oil is not going to be able to dissolve within the water, and it's going to float on top, and so we call that immiscible. And this leads us to the question, why do some things dissolve in water but others don't? If you think back to middle school, you might think, well, oil has a lower density, so it's going to float on water. But that doesn't really explain why it's going to not dissolve, because if we think about salt, salt has a different density than water, but it's going to dissolve into the water and disperse. So we got to wonder, why do things mix and why do some things don't? And the main reason is because of something called polarity. Miscibility is determined by polarity. When we learned Vesper and how to draw molecules, we learned about polar and nonpolar. And one of the things we learned was polar means uneven. We have a dipole that's created because one atom is stronger than the other. Nonpolar means it's equal. Everything is equal on both sides of the bond. So polar substances are going to interact with polar substances. Nonpolar substances are going to interact with nonpolar. We use a term called like dissolves like to help us remember that. So polar dissolves polar, nonpolar dissolves nonpolar. Now what on earth does that mean? Well, let's take a look at some molecules here. In the first one, you're looking at water. And water's got what we've talked about before, the negative end, and it's got two positives down here. And the reason for that is because the electronegativity of oxygen is greater than that of hydrogen. And so those bonds that are shared right here, the electrons, oxygen is pulling it closer to itself. And so since those electrons go towards oxygen, we get this negative charge on this side. Since the electrons are further away from hydrogen, we're going to get that positive charge. In a nonpolar substance like this, everything cancels out because we've got the same atom on all sides. And so there's really no difference. We don't have that positive and negative interaction around the molecules on anything that's nonpolar. We have to remember those definitions. Polar is uneven. Nonpolar means even. Polar is uneven because oxygen over here is stronger. It gives us that charge. Nonpolar, everything's even, no charge. Polar molecules, since they've got those pluses and minuses, are going to produce a strong electrical attraction to other polar molecules. If you remember, opposite charges attract. Polar molecules are going to be able to attract other polar molecules. They can't really interact with nonpolar because there's nothing to attract. There's no pluses or minuses on a nonpolar substance. In order to understand polarity, you really want to understand water and the shape of it. And this is something that I've repeatedly talked about, but you need to know oxygen has the negative end, hydrogen has the positive end. And again, that's because the oxygen is pulling those electrons closer. Water is absolutely polar. It's very, very polar. And so it's going to dissolve anything else that's polar. If we put salts in the water, anything that's made up of a metal or a non-metal with those ionic bonds, that's also going to help dissolve those. If you remember, things that are ionic are made up of plus minus, and it alternates that charge. And those things are all going to be able to interact with water because water's got those pluses and minuses too, and it's going to pull those things apart and help dissolve it. Now, once we've dissolved an ionic substance into water, we're able to identify it based on the ions within there. Now, how do we know ions are present if we can't see them? We can't really put a substance underneath a microscope and look at it, one of the things we can do is we can see if it conducts electricity. So ionic compounds, since they're made up of those pluses and minuses, if we add electricity through the water, if the substance can conduct it, we call that an electrolyte. So we think about all these substances right here, HCl, MgCl2, NaCl, they're what we call strong electrolytes. They dissociate completely into ions. The water up here at the top is going to have pluses and minuses floating all about, and all those individual ions are what conduct that charge and allow the charge to flow in. Now, identifying an electrolyte is pretty easy if you know naming and you know about metals and nonmetals. Electrolytes are going to separate into cations and anions. We've got our metals and our nonmetals, and they're going to allow electricity to flow through. Electrolytes conduct electricity. They are made up of a metal and a nonmetal. So easiest way to think of that, if we've got a question that says, which of the following is an electrolyte? We look at our choices here, and we have to decide which one is made up of a metal and a nonmetal. If you look at carbon, carbon's on the right side of the periodic table. We'd call that a nonmetal. So that one, anything with carbon is already out. Hydrogen, oxygen, both of those are going to be nonmetals. And then the only choice that's left is choice D, lithium chloride. And since we've got a metal and a nonmetal, that's going to allow that to be an electrolyte. So D is our answer. Now, if it doesn't conduct electricity, but it does dissolve, we call that a non-electrolyte. Substances that dissolve but don't conduct electricity, they're made up of non-metals. So they're not going to have the same ionic or ions floating throughout, but they are dissolved. So this is what we call a non-electrolyte. And again, the definition on this one, non-metals. That's going to be our key. Let's look at an example here. Which compound is a non-electrolyte? We go through our choices, and we try and find the answer that's made up of non-metals only. Potassium is going to have a metal in it. Sodium is a metal. Calcium's a metal. And so the only choice that's left is choice D. All three substances here are non-metals. So remember, electrolyte is metal and a non-metal. Non-electrolyte is non-metals only.